Okay, this is the P1 paper from June 2024. It's question number 4, and as we can see, this is a quadratics question. What we're going to be doing is showing where these two curves meet, and because it says that it meets at a single point, that's going to be our work on a discriminant. There's only going to be one solution, one repeated solution, so we're going to get eventually b squared minus 4ac equals 0, but let's just have a look at the question and work out what we've got to do. So we've got curve C1, which has the equation y equals x squared plus kx minus 9. That's a positive quadratic, going to look something like that. We've got another curve which is minus 3x squared minus 5x plus k. And what I know is that when I have those two quadratics there, they're only going to meet at a single point. But if I want two curves to meet, what I do is I put them equal to each other. So let's get started with that. Putting two curves equal to each other, we'll say for the examiner, the two curves meet when minus 3x squared minus 5x plus 6 equals the other one, which is x squared plus kx minus 9. So what I know is I'm going to have one root to this quadratic equation. So let's do the quadratic equation first of all, which means just tidying this up. I'm going to get all the x squareds onto this side here. So I'm going to get 4x squared. I'll get the x's over to that side as well. I'm going to have plus kx plus 5x, I'm going to have the constants on the other side, so minus 9 minus k. That's all equal to 0. Just tidying that up then is going to be 4x squared. I'm going to call that k plus 5 lots of x, and I'm going to call that plus minus 9 minus k for my c is equal to 0. So if it tells me they only meet at one point, they only meet at one point P, what that means is for the quadratic equation, b squared minus 4ac must be equal to 0. There only is one repeated root. So if b squared minus 4ac is going to be equal to 0, b squared is going to give me k plus 5 squared minus 4 lots of a lots of c is minus 4 times 4 times minus 9 minus k. Well, the minus 9 minus k and the minus here, that can all cancel out in a minute. I'm going to tidy this up. K plus 5 all squared. You take your time, but I'll do it quickly. K squared plus 10k plus 25. And then multiplying all of that out is actually 144 plus 16k. Equals 0. Let's tidy that up, but we already know what it's going to be because they told us in the question. It works out to be k squared plus 26k plus 169 equals 0. And that's what we were trying to get for that first part. So absolutely fantastic. I've done part A, sorted out, and then part B says, so now find the coordinates of P, which means finding out what k is, and once I found out what k is, I'll then be able to work out the values of p. But remember, when we're trying to factorize this or put this into the quadratic formula, it's a perfect square here. If I look at this, you can do it using the formula or doing it using anything else, but I'm just going to say that that's k plus 13 squared equals 0. Factorize it whichever way you want, use a quadratic formula, but we're only going to get k equals minus 13. I only wanted one value, didn't I? So if I've got one value here, then the quadratic becomes 4x squared plus 5 minus 13x, and then plus minus 9 minus 13. Equals 0. Yeah, just make sure that's all okay. Where are we? Yeah, plus minus 9 minus 13 equals 0. It was k was minus 13, sorry, plus 13. I thought there was something wrong with that. So tidying that up then, just multiply it all out. We get 4x squared we get plus 5x, well, 5 minus 13 is minus 8x, isn't it? Let's save ourselves a bit of time. So minus 8x, and that works out to be plus 4 equals 0. So solving that, you can either stick it into the formula. I'm going to see if it factorizes. A lot of the time, halfway through these questions, things should factorize simply because it's the quickest way of solving something. So that's actually x minus 1 all squared equals 0 there. So we're going to get x equals 1 as a solution. So if I want to put that, I can put it into either the two formulae. I'm going to use the easiest one, which is x squared minus 13x minus 9. Remember, we know what k is now. So y works out to be equal to 1 squared, 13 lots of 1 minus 9. That all works out to be minus 21. And so p, the actual point, because that's what we're after, is the point 1 minus 27. So quite a bit of algebra involved there just to tidy up that last part, 3 marks and 3 marks. But hopefully if you've done a few of these questions, that should be relatively straightforward. Hope that all makes sense to everybody.